So today we are going to study about NMR spectroscopy. What is NMR spectroscopy? It is first of all we can split this NMR. What is NMR? This is nuclear magnetic resonance. Nuclear magnetic resonance. See, from the name itself we can understand that it is something which is used as a technique by exploiting the nucleus magnetic effects and resonance. So what actually is it is used to study atoms inside the molecule by observing how their nuclei behave in magnetic field. Observe atom. Depending upon how it behaves. In magnetic field. It's not the atom, how the nucleus of the atom behaves. Okay, how the nuclei of this atom behaves in the magnetic field. So this is the basics of NMR spectrum. In NMR spectrum, it uses radio waves, magnetic field, and also the properties of the nucleus. Okay, and what it tells is that every object do have a magnetic field. Okay, so for example, a proton will have a tiny magnet as long as it do have atoms in it. Okay, every atom behaves like a magnet. As long as it do have charge and spin. You know what is spin, right? Denoted by L. So in order to find about if it is NMR spectrum active or NMR inactive, we need to find out the atomic number or the mass number of an atom. If the mass number or atomic number or mass number it do have two possibilities. If it is odd or if it is even. If it is odd, it means it is active. What active? NMR active. If it is even, it is NMR inactive. And so its application or its uses is, we can tell that it is helped in identifying the different types of hydrogen atom. To identify, first one is identify types of hydrogen atom. Second property is to understand which atom is connected. We will discuss about how we will identify or to understand the atoms later. Okay. And the third property or the third use is to determine the structure of a molecule. Okay. Molecule. To find out the structure of a molecule, this spectroscopy is used. So which of the nuclei can be used? The nuclei which can be used are any nuclei having a non-zero spin. This is same as what we have written here. Okay. Which have an odd number of atomic number of mass number will have what? Will have a non-zero spin number. So this is, we are writing it again. Any molecule having a non-zero spin number shows or is NMR, can be used in NMR. Okay. So example is one it's and carbon, 13 carbon, 19 fluorine. Okay, there's one question, if 12 carbon can be used? No, because why it cannot be used is that its atomic number is 12, which is even. Can be also said that it is diamagnetic. So here comes another property or another definition of whoever is NMR, whoever can be studied by NMR, those who are only paramagnetic can be studied under NMR. So what we are going to discuss next is what happens when a nucleus is placed in a magnetic field. So this is basic thing. Whenever a nucleus is placed in an external magnetic field is given by B0. Whenever it is placed in an external magnetic field, it can either align with or against the field. So let me say it is north. This is a magnet. It's an external magnetic field. So its field is in this direction, right? From north to south. Whenever it is this, it can the nucleus can align either towards, along with, or it can align against. So what we were saying that in an external magnetic field, we are like placing a nucleus, an atom, or our sample between the external magnetic field. So what happens in this external magnetic field is that by from the diagram we see that whenever putting it in an external magnetic field like this, I'm putting in an external magnetic field, it can either align along with or it will be against the field. Okay, so in both the cases there are some terms used. So there what it means is that if it is, let's mark the against one in another color. Okay, so what does this mean? Against the field means it have higher energy state, and it is referred as beta spin state. Along the field means lower energy state, and it means it is called alpha spin state. So there are two spin states in this. It keeps on alternating from alpha and beta, and this will make us identify the structure of a molecule. Okay, these it jumps between these energy levels, and subsorption is what we detect in NMR. Okay, so it's this principle, what how it's this principle from which we are using NMR spectrum. Okay, so so what we were telling by now is protons. It's about proton light. So this nucleus will have electrons also. Okay, nucleus will have electrons. So what is happening is one minute. What is happening here is, this is the external electric field, and this one is the protons, and it will have electrons. It will have electrons around it will be formed during the external electric field. Electrons will be there, and whenever there is presence of electrons, it will induce a magnetic field opposite to the external field. There will be an magnetic field, induced magnetic field opposite to B0. And this is what we call shielding. Okay, so whenever there is shielding, or we will say it is shielded. Whenever it is shielded, what we say it is upfield. And in upfield there is weaker effective magnetic field. So what is effective magnetic field? If beta effective is B0, it is external, minus B induced. So whenever there is B induced, the effective magnetic field will be lesser, so lower effective magnetic field, and a lower effective magnetic field, and during and there is another phenomena called downfield. What is downfield? Next is, what is downfield? This is opposite to it, that is, whenever electron density is very low, it won't produce, the electrons are not sufficient enough to opposite the external electric field, sorry, external magnetic field. Okay, external magnetic field. So the effective magnetic field will be high. So it only resonates under high frequency. This is what we call downfield. Downfield under, and this is de-shielding. Okay, so we understand what is shielded and de-shielded in the case of protons and it depends upon the electron density, and whenever there is a lower electron density, there will be a de-shielding or a downfield. Okay, so let's summarize it. Summarizing it, I'm telling that in upfield, just remember this only, whenever there is an upfield, there will be a lower magnetic field, effective lower magnetic field, so lower frequency, lower ppm. In the case of downfield, there will be higher magnetic field, higher frequency, so higher ppm. And these frequencies are then detected on it like peaks, with peaks. Okay, so what exactly is the area under the peak? So area under the peak represents or is proportional to the number of protons. So that is a question regarding the find out the number of peak in methoxymethane. What is methoxymethane? CH3 or CH3. So in this compound, both the functional group are same, and both the functional group has two different hydrogen atom, but they are equal in environment. The two methyl group on either side of the oxygen atom are identical, isn't it? These are identical, and so that as this molecule is symmetrical. Okay, this molecule is symmetrical. CH3 on both sides, a middle oxygen. This molecule is symmetrical. These hydrogen atoms, there are 6 hydrogen atoms. All the 6 hydrogen atoms have same environment. Therefore, we count it as one. There is only one distinct environment. So the number of peaks will be 1. Number of peaks is equal to number of distinct hydrogen environments in a molecule. Let's look up to the next similar question for practice. So another question asks us about number of peaks in ethanol. Ethanol is CH3 CH2OH. And this compound, how many peaks will be formed if this sample is used in NMR spectrum? In this, there are two signals. So first of all, what all functional groups are present here? There is a CH2, there is CH3, and one OH. This will form what? The compound will be CH3 CH2 CH3 CH3 CH2 CH3. There will be 3 groups in it. There will be 2 distinct group. What are the 2 distinct group? The 2 distinct group are, one is CH2 and the other one is CH3. So there will be 2 peaks forming in this one. Sorry, the question I have read the question wrong. It is CH3 CH2 CH2. This is the compound. Okay, CH3 CH2 CH3. Another question is, a compound shows 2 peaks with integration ratio 3:2 and the splitting pattern triplet and quadrat. What type of group is present? So we can find the type of group.